Hello and Assalamualaikum to Dr. Durazak, our lecturer, and fellow friends. So today we will present about our study title named Analysis of COVID-19 Deaths Datasets. So we aim to investigate how COVID-19 affected death rates by looking at the weekly access death that been collected in the KGO, the dataset, which are data about the expected number based on historical data. And this study will help us understand the broader impact of the pandemic, including indirect death due to the overwhelmed healthcare system or delayed treatment. And these insights are crucial for public health planning and policymaking. We selected the all weekly access dataset for our analysis because this dataset includes all detailed information on weekly access death during the COVID-19 pandemics across multiple countries. The key attributes include nation, region, total deaths, COVID-specific death, and expected death. Our initial observation show a significant variation in excess death rates across the nation, with some countries experiencing much higher rates, indicating a severe impact of the pandemics. We also identify the potential outliers in the excess death and COVID death columns, which will require further analysis. The knowledge discovery in database, which is KDD process, is a systematic approach to extract insight from data through several stages. First, we select a relevant dataset, which I mentioned just now from the KGO for our study, which is a dataset with detailed information on weekly excess death because of pandemic COVID-19. Next, we process the data by cleaning it, removing errors, and normalizing it to ensure comparability. In the transformation stage, we create new metrics like death rate variation and week-to-week variations. During data mining, we apply models such as KNN, K-nearest neighbor, support with vector machine (SVM), and naive bias to find the pattern and predict excess death. Finally, we evaluate the model's performance using metrics like accuracy and precision. This process really helps us gain valuable insight into the pandemic impact on the death rates.
Let's move to data preprocessings. My name is Boniface Basik and I'm Mukine with number metric 83396. When working with datasets, it's essential to handle various data preprocessing steps for maintain the integrity of our analysis. Here are complete guides. First, import the necessary libraries such as pandas for data manipulations and analysis, NumPy for numerical operations, Seaborn for statistical data visualizations, Matplot for creating various type for visualizations, and OS for interacting with the operating systems. Next, load our datasets using PD read CSV to read the CSV file, name all weekly access stats to CSV, and store the data in the data frames called DF. After loading the datasets, define which values should be considered missing, such as and, NA, NA, and NP.N. Specifically, this value in list and use the NA values parameter in PD read CSV to replace them with NaN. To recheck the missing value in each column, use the F is null point sums, which provides the count of missing values per column. Additionally, use the fnull any to get a boolean indicator for each column showing whether any missing values are present. If missing values are detected, remove them by df drop na. Finally, verify the removal by checking again that df is now any to ensure no missing value remain. Next, handle duplicate entries by using the fdrop duplicates, country, regions. We can choose any columns that we want to remove the duplicate, which remove duplicates row based on the country and regions columns. ensuring each entry is unique across the datasets. Finally, identify and exclude irrelevant columns that are not needed for analysis. This improves datasets clarity and focuses on relevant data, such as from our datasets, which is region code, that's not really important for our datasets and clean. So I remove the irrelevant data and enhancing the efficiencies of data pre-processing and analysis. By following these steps, we can ensure that our datasets is clean, unique, and ready for analysis. That's all for data pre-processing. Thank you.
Hello, my name is Delicia Dylam Anak Wilson with the matrix number of 83655, and I will be presenting and explaining a bit on the codes that I did for the 4 classifier algorithms. Okay, so hello again. So let's go straight into it. So let's start with decision tree first. So so this is, let me zoom in a bit. So this is the library we use, but I put everything here, including KNN, SVM, and Gaussian naive Bayes. But for this part, I will. But this, for this entire row, it's only for decision tree. Okay, so I'm skipping this part because it's basically just reading the data set, and a lot of this part is actually the pre-processing, which I will assume Bonnie will do the explaining. So let's go straight into where I utilize the decision tree algorithm. Okay, so this is it. So this is when I experimented with it first. So I went with the feature population, and the target column is total death. So here we made it about read the values from the dataset, and here the categories, because I did had some problems with this particular part, because apparently the dataset is for regression. So what I did was what was recommended for me to do by ChatGPT, of course, was to do the binning. So this is what I did here, binning, which there's 3 categories: low depth, medium depth, and high depth. So here I verify the conversion, and here I do the printing a bit. Yes, here printing for the category. So in this part, I split the data into training set and testing set. So here we can see it here, and then I initialize it, training, making predictions, and evaluating the model. So this is the, and also visualizing the decision tree. So this is what we got, but I wasn't quite happy with it because it looks a bit too like simple. So but this is the confusion matrix, but I'm gonna skip that part because I have a better one down here. So I then try with 2 features: COVID deaths and non-COVID deaths, and the target is total deaths. Again, I make it read the data, and then here we can see once I do the bidding, similar as what I did above. With this PD card to create it, be handling any missing values, splitting, initializing, training, making predictions, evaluating, and then visualizing the decision tree. And then we can see here, this is a much better looking decision tree, which I'm satisfied with. And then once I'm happy with my decision tree, I then went to do the visualization for the confusion matrix, as we can see here. So there you go. This is the confusion matrix, which my friend Anis will elaborate a bit more further. So let's go straight to SVM next, because that is the second one. So again, this is the library reading the dataset. So this is how I utilize it. So in this, for SVM, I selected 2 different features this time. Instead of total deaths, I went with excess deaths, as well as COVID deaths and non-COVID deaths. And then splitting the data as such as before, and then using the scalar here, and then creating the model, training the model. And let me just run this for so you can see clearer. Okay, so yeah, so here we can see the evaluation for the model, the precision, the recall, the F1 score support. And my friend will do the comparison in more detail for the next section. So this is the confusion matrix for that. Yes, this is the confusion matrix. And I also tried a different approach of visualization because I felt like I needed to do more. So this is what I got, which is I can do the receiver operating characteristic curve. I'm not sure, I don't really understand it, to be honest, but it's a very interesting visualization. And this is the part, the I think this is the part where I'm excited with, because this is the decision boundary. I thought it was very cool. So this is the syntax turned into pictures. Similarly, okay, splitting, I think it's similar to how decision tree works, just there's a few difference because here we have the creating the mesh grid and training the SVM model here. So this is the decision boundary for that dataset using SVM classifier algorithm. So let's go to KNN next, the third one, K nearest neighbor. So here we read the data again, the library and reading the data. So with this part, I actually wanted to see the data types for each of the columns. So here we can see it actually. So okay, so now again for the features, I chose a different one this time: population, COVID deaths, non-COVID deaths, and excess deaths. And then I split the data here. This part is splitting the data. Okay, splitting the data and then initializing the KNN. This part too, and then this. And this one is the evaluation. You can see the precision, recall, F1 score, and support. And then for this one, I wanted to see the scatter plot for population and excess deaths, but I wasn't quite happy with how it looks, so I tried a different approach. COVID deaths and excess deaths. This looks way better. And I also tried non-COVID deaths and excess deaths, which is the opposite actually. That's so we can see it has a much, we can see the grouping, the clustering is quite different. And then I tried non-COVID deaths and COVID deaths, and there we go. We can see it here, the visualization. This is very interesting. I like doing that part. So this is the confusion matrix for that, for the data set. You can see the syntax with the features and targets, splitting, scaling, quite similar, almost quite similar syntax. Just a few differences here and there. So, we can see here the to initialize the KN classifier. Is it, here we can, I think, where is it? I use 5 if I'm not mistaken. Yeah, there we go, 5. So this is what I did, and then then it came out like this. This is the confusion matrix for that data set using K nearest neighbor classifier algorithm. Okay, so what is down here? Yes, down here is the decision boundary for KNN classifier with the K as 5. So this is the syntax. Scaling, initializing, I think it's almost the same. Just you have the mesh step size here, and then a few reshape and prediction there, and then plotting it. So you cannot see this. And this is the decision boundary for the classifier, for the KNN classifier. Looks quite interesting. This is the confusion matrix again for the heat map. So now let's go to naive Bayes, the last one, the last classifier algorithm. So similarly, again, the library, reading the data to check it. So here I initialize the algorithm. And also, just to note, we use Gaussian naive Bayes because if I'm not mistaken, there are 2 more different naive Bayes types, but we chose to use Gaussian naive Bayes. So again, building the excess deaths into categories, similar to what I did with decision tree, and selecting the features, then splitting the data again, initializing, training, and evaluating. And this is the evaluation for the model. And I also computed, here's the confusion matrix. Wait a minute, okay. So this is the confusion matrix for the dataset using Gaussian naive Bayes classifier algorithm. So this is what, and this one did. Okay, so this is the decision boundaries. So yeah, I think there's not much difference in the syntax except for initializing the types of classifier algorithm. This part is quite different if I'm not mistaken. So this is the decision boundaries for our dataset using Gaussian naive-based classifier algorithm. So those are the 4 codes that I did for the 4 classifier algorithm, which is decision tree, support vector machine, k nearest neighbor, and Gaussian naive-based. So that is all from me. Thank you very much.
The chart compares the performance of four classifiers, tree decision, support vector machine, k-nearest neighbors, and knife bayes using four metrics, which are accuracy, precision, recall, and F1 score. Knife bayes is the best performer with scores close to 1.0 across all metrics, indicating it handles the data set exceptionally well. The decision tree classifiers also performs well, with all metrics close to 0.9, suggesting high reliability. KNN follows closely with scores around 0.8, indicating good performance but slightly lower than decision tree. SVM, however, shows moderate performance with accuracy and precision around 0.7, but significantly lower recall and F1 score around 0.6, suggesting it struggles with identifying positive instances correctly. Therefore, while MyFace is the top choice for this dataset, the decision tree and KNN are also strong options, whereas SVM is the least effective. Confusion matrix is a diagnostic tool utilized to assess the efficacy of a classification system. True positive refers to the count of events that have been accurately forecasted as positive. True negative refers to the count of instances that are accurately predicted as negative. False positive refer to the number of events that are wrongly forecasted as positive, also known as type 1 error. False negative refer to the cases that are mistakenly forecasted as negative, which is also known as type 2 error. The decision tree model exhibits excellent performance. Its confusion matrix suggests an accuracy of 0.85, a precision of 0.78, a recall of 0.88, and F1 score of 0.83. These metrics indicate that the decision tree model is highly reliable, with both precision and recall being quite high, resulting in a balanced and robust F1 score. The SVM model, on the other hand, shows moderate performance. Its confusion metric results in an accuracy of 0.75, a precision of 0.67, a recall of 0.75, and an F1 score of 0.71. Although the SVM model performs reasonably well, its precision and recall are lower compared to the decision tree model, leading to a somewhat lower F1 score. For the KNN model, the confusion matrix reveals strong performance with an accuracy of 0.81, a precision of 0.73, and a recall of 0.82, and an F1 score of 0.77. The KNN model is particularly notable for its high recall, making it a dependable model with well-balanced precision and F1 score. The naive-based model shows the lowest performance among the four. Its confusion matrix results in an accuracy of 0.65, a precision of 0.56, a recall of 0.62, and an F1 score of 0.59. These metrics indicate that the naive-based model is less effective for this classification task, with notably lower precision, recall, and F1 score. In summary, the decision tree model stands out as the best performer with the highest accuracy, precision, recall, and F1 score. The KNN model also shows strong performance, while the SVM model has moderate effectiveness. The knife-based model, however, has the lowest performance matrix, making it the least effective in this comparison.
The image depicts the classification process of a software vector machine, SVM, algorithm which effectively segregate data points into two distinct categories, anticipate, access depth, and non-access depth. The color region depicts the decision boundary established by the software vector machine, SVM. This further determines the classification of data based on scale counts of COVID-19 and non-COVID-19 data. The points are assigned color based on their respective categories at the access or non-access depth. This color coding aids in visualizing the SVM ability to effectively differentiate between this category in a two-dimensional feature space. For the KNN part, the diagram visualizes the classifier decision boundaries in two-dimensional feature space. The shaded region represents where the KNN classifier predicts different categories of assessment that, while points are colored based on their actual categories, showing how well the model separates the data. Naive Bayes decision boundary. The scatter plot visualizes data points colored by their categories. The decision boundaries plot overlays a color gradient representing the model predicted probabilities across a grid of potential data points, showing where the classifier predicts different categories based on their feature week and COVID depth. The color intensity indicates the probability of each category, helping to visualize how the naive Bayes model separates the data.
Good day to Dr. Raza. We are here together for group reflections and our roles about what we have implemented in this group project. So for this group project, I have been in charge of data pre-processing. Throughout my role, I have enjoyed coding and cleaning the data, drawing insights from YouTube tutorials on data cleaning and engaging in discussion with my friends, which is my group mates. And I owe them a big thanks for their supports and thank you guys for helping me to clean my data. Also, the effort you guys have been helping me. And for my responsibilities have including removing missing values, eliminating duplicate data, and removing irrelevant columns as part of my data cleaning job scopes. I have effectively fulfilled these tasks within the data cleaning job scopes. And additionally, I have contributed by explaining the data pre-processing concept into video presentations and documenting them in reports and creating slides for presentations. And I also source the datasets from Kaggle website and use the suitable datasets for our topics. That's all from me. Thank you.
So that is my name, Mohamad Fatihin, and I'm responsible in identify and select a stable dataset related to the chosen classification topics, conduct an initial study of the dataset, and prepare a brief report and KDD process and KDD process. So our study investigate the broader impact of COVID-19 on death rates using the weight access data that been selected in Kaggle and following the KDD process. In this process, we randomly select a process dataset to reveal significant disparities in excess death rate among the nation. Insight indicate correlated with the pandemics, highlight the direct relationship between the infection rate and the death. Challenges such as data inconsistency and model limitation need to robust data, exploring demographic influence and integrating the data. Overall, the findings emphasize the importance of proactive public health strategies and data-driven decision-making to mitigate the future health crisis. That's all.
Should I go next? Anyone else want to go? Okay. So hi, my name is Delicia Dylam with matrix number of 83655. So I was in charge of doing the coding and the programming of the 4 classifier algorithms, which are decision tree, k-nearest neighbor, support vector machine, and naive Bayes. So I had a lot of help from YouTube and also ChatGPT, as well as a few websites like DataCamp and Geeks for Geeks. So I did have a lot of help from them, especially ChatGPT. But although, even so, I did have a few challenges because for decision tree, for some reason, it won't create the decision boundaries for some reason. And I think from ChatGPT itself, it says that it needs to do a regression algorithm instead of a classification algorithm. So that was one of the challenges that I faced. I also faced because our dataset is very huge, I think around 5,000, if I'm not mistaken, right? 5,000. So it was very huge. So it was unable to do the naive Bayes. And so yeah, that was one of the challenges that we faced. Even so, we were able to implement the confusion matrix into all 4 of the algorithm, which I think was very good. Overall, I think it was a very fun experience. I think it was for me personally. I think it was better than a few projects that I did before. This was much more simpler, and the syntax was just a bit shorter and simpler. So that's all for me. Thank you.
So my name is Dayang and Nazirah, 83632.
So for this assignment, I conducted an evaluation of 4 classification algorithms comparing their performance with detailed metrics like accuracy, precision, recall, and F1 score. I used like a graphical representation like a bar chart to compare the accuracy, precision, recall, and F1 score. I visually highlighted the differences in their effectiveness, adding clear interpretation of strengths and weaknesses. So for this assignment, I faced like nothing challenges faced and strategies, but overall it was good and it was fun doing this assignment. That's all.
Hello, my name is Trinnasius and I'm from JK. My metric number is FF9. For this assignment, I'm compiling the final report involving organizing each section meticulously, ensuring clarity and adherence to API format from the project data and appendix. I focus on providing clear instruction for running the Python code, detailing syntax step, and command line usage crucial for others to validate our method independently. Besides, I also have crafted the presentation, working closely with team members to ensure it effectively communicate our project key points. Reflective on this task, I see the importance of clear documentation and teamwork in conveying technical insight effectively. Describing the diagram added to this clarity. Other than that, this experience significantly improved my skill in project management, writing and presenting, and benefiting both my personal and professional growth. That's all from me.
So Bonnie, do you have anything to say? Like your problem
Oh,
with this
thank you,
assignment?
Dayang. So I have things to add, which is what I found, what I think like the limitation that I have, which is my data preprocessing, which is the noise things and correlated and discretions. And I need to make it because yeah, the data set is really big and the limitation is that yeah, it's hard to find. It's hard to find how to do it, but the YouTube also like don't show that quite much. So and I also asked some of our friends also, which is they said it's actually depend with your data sets. If your data sets is so much crash and so much that have missing values or so many duplicates, you need to do the noise things correlated and also discrete. And since our data sets is so big and not so many missing values have and not too many duplicates, and yeah, I don't put the correlated and the discretion and removing noise. Yeah. And also I also struggle with because ChatGPT or some of ChatGPT don't really give me a good feedback with the coding things. So I need to find the manual things, which is YouTube. YouTube teach me and also ask you guys, which if you guys know how to do this well as well. And thanks for the help. Yeah. Does anyone have anything to add?
No, so far, no.
So thank you so much, guys, for really contributing in our group project, and I'm looking forward to working with you guys in the future. And thank you for Doctor for teaching us how to do the algorithm things and the programmings. And yeah, have a good day, Doctor. Bye.
Bye. Thank you.